Okay, so before I start, I'm just gonna pass some handouts. These handouts are not critical. It's just for you to see some information. Just gonna pass some to you and some to you guys. So okay, so first of all, good morning, everybody.
Good morning.
Just a little quick of introductions. I'm here to talk to you about some robotics, especially for the farming industry. I'm not in the. If you see your program, I'm not here. Okay, it's just because I was called at the last minute because I think somebody canceled. But I'm still gonna try to give you some information about robotics and things. So my name is Alex Ramirez. I wear two hats. One is I'm the CEO of a company in Calgary called Forefront Robotics, where we do unmanned vehicles. Now we don't call them much robotics, but we call them more unmanned vehicles. And in the agricultural business, you can call an autonomous tractor an unmanned vehicle, a aerial sprayer, an unmanned vehicle, and so on. So that's what we do, and we have been focusing on what we call confined spaces, collapsed buildings, mines, and even though here usually in farms you have open fields, this is still a confined space. Why? Because sometimes we have to go within the crops. Okay, so that's one of the hats that I wear. The other one is also I'm also a professor at the University of Calgary, where we develop unmanned vehicles for different purposes. And one is that we have been working a little bit with smart farming to try to use robotics for precision agriculture. Okay, so have you heard of the word precision agriculture? Probably you have, right? So before I start talking about robotics, who use robotics in their fields? Raise your hand. You use what type of robots do you use?
We use drones to do aerial mapping and
Good.
NDVI.
Okay.
surveys.
Do they work?
Sometimes.
Sometimes.
Sometimes the program fails.
Okay, so yes, just to start, because you're the only one that raised your hand. What is the main challenge that you see?
Yeah, like it's when we fly, stitching all it creates this big data
Sure,
set,
sure.
and then putting all of that data set into something that actually
Sure, makes sense, right?
Yeah, it makes sense.
Okay, good. It's good to hear that at least robotics are starting to be used, at least in Alberta. In many countries, they are using it more extensively. So I'm going to be talking to you about two systems. One is drones, unmanned vehicles, aerial unmanned vehicles, and the other one is ground vehicles. From my point of view, there is no single robot that will do all the tasks. Some people think that a robot will be able to do A, B, C, and D. But that's not the case. So the first thing that I'm going to be talking about is about robotics. And as I said before, specifically aerial vehicles. So in your handout on the back or in the front, you see this vehicle. So that vehicle is a 3 meter, you can see the data there. It's a 3 meter length helicopter, which was developed by Yamaha and was developed specifically for agricultural purposes. How many of these vehicles do you think we have in Canada? In Japan, they have hundreds and maybe thousands. They were specifically designed for farmers in Japan to spray their rice. And if you have been to Japan, you see a rice field here and there and there and there and there and there, everywhere, even in the city. So we're trying to push these unmanned vehicles here in Canada because they are really useful. So you have been using drones. Quick question, what's the size of your drone?
Oh, it's like a little EV. It's about this big.
This big?
Yeah.
Quick question. How,
This big.
Oh, you
You're-
have an Inspire? Oh, okay.
so, quick question. How long does it fly?
About 45 minutes to an hour, maybe.
Is that enough?
No, we have to land it and.
Sure.
Yeah.
How long does yours fly?
Minutes of battery.
25 minutes and that's it, right? Is it enough? So there's two types of drones. Many people right now, farmers and things in many countries, not just in Canada, are using the small ones. One of the things that you have to be aware is Transport Canada. In order to fly these things, you have to have a permit from Transport Canada. Why? Because you might be invading commercial airspace. And if that's the case, you might put commercial aircrafts in danger, especially if they are fully autonomous. Many of the drones that you might be seeing or who you have used, you need a pilot. Would you like to have a pilot?
Ours is semi-autonomous.
Sure.
It'll fly itself, but
Sure.
you can also take command.
Sure. Is yours fully autonomous? What would you like to see? I'm asking you because you're one of the guys that have drones, right?
Yeah.
So that everybody not just sees my take, but it also hears from you. So would you like to see something fully autonomous? That you just press the button and say, do this, do photogrammetry, analyze my crop, spray things. That's our goal. Okay, so anyways, but before I go into that, so one of the things that you have to be aware is Transport Canada. You cannot fly these things above 400 feet. If you fly above that, then you're invading commercial aerospace. So most of the cases, that's why we use smaller drones, because they have a top ceiling, and if they cannot fly higher than a specific ceiling. The other thing is that if your drone weighs more than 25 kilograms, you cannot fly. Doesn't matter what altitude, just because of danger and things. And I think these things over in the future, they are gonna be being relaxed. You're gonna be able to fly bigger drones, bigger machines, and so on, just because people are gonna be getting more used to it. Right now, public perception is it's a concern. Even though these machines work really well, and sometimes you say fail, there's also the concern that if something happens, who is going to be responsible? Quick question for you guys that have drones. Do you have insurance for a drone?
Yeah.
You have insurance for a drone? So most people, not just in Canada, but in the States, about 95%, they use drones and they don't have insurance. One reason for that is that sometimes many insurance companies, they say, what? I don't know how to insure that. And if the drone crashes, who are they going to blame? You, the designer, the software, the guy that developed the aircraft, they don't know who are they going to blame. Not to put blame or something, but usually that's what happens, right? So anyways, so for using drones, you have to be aware of those things. You have to fly below a specific height, 400 feet, at least here in Canada, and those rules might be changing in the future. They're always changing. Transport Canada is always adapting and changing conditions and regulations, depending also what happens in the States. Okay, the flight time. This vehicle that you see here, in Canada, as I said before, we only have one. And in Japan, as I said, they have hundreds, and they use them every single day. This vehicle can fly for about 2 hours, can carry up to, at least in Calgary, about 50 pounds of payload, which could be fertilizers, either granular or liquid. It could carry different equipment. But once again, it's difficult to get a permit from Transport Canada to fly this because they don't know it that much. Okay, so that's in terms of Transport Canada.
So what's that one worth?
What's that?
What's that worth?
This one, you cannot buy it. But when you could buy it, and I can explain you why you cannot buy it. When you could buy it, it will cost you minimum $250,000. The minimum, the bare minimum, that is just a machine that flies, nothing else, no cameras, nothing. And eventually I'm going to talk a little bit about cameras and things. As you might be aware, also drones might be used for, as you said, for inspecting the crops, either the health of the plants, the water content of the soil, and for that you have to load equipment. Either different sensors, such as, for example, multispectral cameras. A multispectral camera might cost you $50,000. Depends on the type, right? You might buy one that is $2,000 and one that costs $75,000. All depends what you need. So hopefully in the future, Transport Canada is gonna relax the regulations so that you can fly this. And right now we're trying to bring this technology into Canada, not just import it, but also develop things here. Why? Because here the conditions in Canada are different from other parts in the world. In Japan, they use them quite a bit. And these machines have been developed specifically for the climate, altitude, and all those things in Japan. So if you have driven a remote control car, for some might be easy, for some might not be that easy, but these are 10 times easier to fly. I have trained people to fly this in 5 minutes. So that's one of the things. So so drones can also be used for spraying, right? And in Japan, that's their main usage. Here in Canada, we have been trying to use drones to spray things, but we don't know exactly how they work. Once again, I'm not a farmer, but we have been receiving feedback from farmers that sometimes how the drone spray things, pesticides, herbicides, fertilizers, seem to work better in some plants than in others. And that just because you have to be aware that when we use the technology, it's not just one recipe. Usually you have to consider different factors. You have to consider at what height you fly, how much you spray, the separation between the plants, the separation between the rows, even the type of plants. If you spray, once again, I'm not a farmer, but if you spray on a specific field with plants of a specific type that have been planted, for example, have been planted for a week, and then you spray the same type of plant with the same conditions that you planted, and those plants were probably planted 2 weeks before, the fertilizer doesn't act the same, or the pesticides, for some reason. And people are trying to identify why this is. So that's drones, just in a nutshell. Now the ground vehicles. One of the factors that drones cannot do, basically they are looking at your crops from the eagle's point of view. And when they spray and when they analyze your crops, basically they are seeing everything from above. But sometimes you have to deal with things that are inside the crop, such as weeds or pesticides, insects, and so on. And sometimes it's difficult to see them from the top. So we have been developing, and there's ground vehicle technology to do and inspect crops in these cases. So now the challenge with the ground vehicles inspecting the crops from the ground level, what do you think will be the challenges? What are the challenges that you face? You as, what's that?
Plant identification.
Plant identification, good. Like, for example, identifying weeds. I'm assuming, you're much better to identify weeds than I do. I see a plant, and for me, it's a plant. Once again, I'm not a farmer, right? But you might be able to say, oh, that's that weed. I don't even know if this is a weed. I have no idea. But we have trained robots to be able to tell us if this is a weed or not, right? Even though I don't know it. So the problem with trying to make ground vehicles identify weeds is a challenge. Why? Because right now we're using artificial intelligence, but we rely on something that is called machine learning. And to do machine learning, we need data. And we don't have that data. I don't think you have that data. How do you identify weeds?
I phone my neighbor.
He phones your neighbor. It's good, right?
Neighbor, not the dumb neighbor.
Sure, if it works, right? Do you identify weeds? Or can you identify weeds?
From the other crops?
Yeah,
From the dimension of the crop, dimension of the green area.
Okay.
You can train your model.
No, but you.
Ah, by myself.
Yeah.
Yeah, I am agrometeorologist.
Yeah, but
I should.
so basically you identify weeds by experience. And you have learned that that's a weed and that's not a weed. So if I give you 2 plants, and right now I'm just picking random from the soil, right? But let's assume that these are 2 plants. And I ask you, which is the weed? Which one is it?
Maybe better to ask which is wheat and which is barley.
Sure.
That is better to no,
Sure.
I cannot distinguish.
I cannot distinguish either, but we can train machines to do that. So anyways, we have trained, just a quick story. A quick question. If a baby is born and somebody shows you a picture of their face, can you tell me if it's a boy or a girl? No?
Some babies
No?
Yeah, they're potatoes.
So I cannot either, right? It's potatoes, right? But we have trained machines that can do that. 99% accuracy. We give them a picture and they will tell us it's a boy, it's a girl. And 99% of the time, the machine is correct. But we need data. We need pictures of kids. And we show it to the computer or the robot. Tell me, is this a boy or a girl? A boy. No, it's a girl. Another picture. Is it a boy or a girl? A boy. No, it's a girl. And so on. So we train them. So little by little, they start recognizing things. And for that, we use artificial intelligence, machine learning. With weeds, we have been trying to do the same thing, but there's no database that we can use to train the robots with weeds. And it's not just that we show them a picture of a weed. We have to show them pictures of the same weed at different levels of health conditions, height, humidity of the ground, all those things. We have to give them all this information, and it's hundreds of millions of potential pictures. So that's the challenge with ground vehicles. We can use them, but we have to train them. And one of the things that I think you guys are amazing, farmers, is that you can do these things, but the thing is that you don't have a recipe, right? Can you identify weeds? Yeah? Can you give me a recipe so I can use it? Nope. And if he has it, he keeps it secret, right? So that's the challenge. So in ground vehicles, what we're trying to do, and there's technology worldwide, where we can use machine learning for specific types of weeds where people have been trying to collect the information, gather lots of pictures, images, different type of data, and train robots. So we're able to guide a vehicle on the field, and the vehicle will tell us where are the weeds, precisely, GPS coordinates. And if we're able to do that, right now we can do that with about 85, 88% accuracy. And if we can do that 100%, then we can start spraying pesticides, not just from above, as I said before, with aerial vehicles, but also from the ground, and target specific weeds. And basically fighting the root cause of the potential problem, and not just spray everything. Because as I said before, some crops are susceptible to different types of herbicides and pesticides. You spray things and you might kill the weeds, but the plants also might suffer. And once again, I'm not a farmer, but I know that happens. Okay, questions so far?
So why don't you just do it the reverse way, where you identify the crop, and then anything besides the crop is like labeled as a weed, and then you don't have to deal with so much variance.
Yeah. For a number of reasons. One reason is that if you identify the good guys from the bad guys, you tell the thing, if it's not a good guy, kill all the other ones, right? So what you might be doing is that you save your crop, your specific plants, but you might be killing something else, right? For example, just a quick reference. In the UK, they use autonomous seeders and different types of machines in their crops. And they use them to harvest and different things. But before they release these machines, the farmers have to go to the fields and try to remove as many as possible animals that nest in those fields. So if you tell the robot, kill everything except the plants, you're gonna go there and kill everything. So in the UK, farmers do that because there's a concern that they are killing lots of fauna or animals and plants, right? They go there. In the past, they were killing lots of different deers and different creatures that will nest on the crops. So that's a concern. And once, all depends how you want to do it, right? If you want to say, well, identify the good things and destroy I'm using the word destroy, right? But kill the other plants, you have to make sure that the conditions are right for you to be able those machines to do that. Otherwise, you might be destroying things that you might not want to do. Okay, any more questions before I continue?
So how do you deal? How close are you with dealing with ranges of
What's that?
plants? How close are you dealing with the robotics identifying the ranges of the plant from a 1-leaf to a 4-leaf to?
Well, we don't go with leaves, and sometimes, to be honest, we don't know how the machine is learning. We have algorithms that learn these things, but it's difficult to pinpoint what are the characteristics that the algorithm is looking at to identify things. Quick example. In the U.S. Navy, I used to work for companies in the States. So in the U.S. Navy, in the Army, many years ago, about 20 years ago, they started using computer vision in their tanks. They wanted to automate these tanks. And probably you're aware of these things. They use drones and things, right? So they started training them to recognize between the good guys and the bad guys. So they reach a level, they achieve the recognition 100%. 100%. And they said, yeah, we're ready to demonstrate this to the generals. And they set up their demonstration, push the go button, and everything started going haywire. The tanks started destroying the good guys and the bad guys. And then the US Army said, what happened, right? And what happened is that when they were training these things, they were training them in a lab setting condition. So the robots were able to identify these things, but were able to identify these things just by the shape of the vehicle on the ground. Just because there were lights and things, and they would say, well, if this shape has these characteristics, or this shadow, it's an enemy, or it's a friend. And when they release it on the field, the shades and the shadows and things change. And the system thought that everything was an enemy. So it's difficult. Once again, sometimes we don't have the recipe. Right. Sometimes we train these things with to the best of our knowledge and techniques, but sometimes we don't know exactly how the system is doing it. As I said before, a machine recognizing between a boy and a girl if you show them the picture of a 1-day-old baby. We don't know. I don't know how it does it. I mean, you can start digging into the things, but we don't know. And that's the controversy about artificial intelligence. If I ask you a question, who is afraid of AI? Raise your hand. What are you afraid of AI?
Movies.
Terminator, for instance.
Okay, but that's Hollywood, right? Well, somebody else raise your hand over there.
Well, it's just we can disguise things, right?
What's that?
We can disguise things.
Yeah,
And it's the disguise that I'm worried about.
yeah.
See, I think I was pretty good until you made the comment that you don't know how they understand or how they learn.
We don't know. Sometimes we have an idea, but we don't really know.
That's the scary part.
Yeah.
This is how I see it. We need help. I think we know. Do you know how billions of people live in the planet?
We're up to 7.5.
A little bit more.
Oh, good.
A little bit more. That was maybe 3 years ago. Right now we're about between 9 and 10 billion people in the planet, and we have to feed them. And people like you have to grow all these things to feed all these people. Pipelines. You know, we're in Alberta, oil and gas province. We have to inspect pipelines to prevent leakages, right? Somebody wrote a book, and they said that in order for us to inspect pipelines and keep them leak-free, and somebody came with this number. I'm not sure how they came up with this number, but they said the entire city of Calgary, and in Calgary, you know, there lives 1 million plus people. The entire city of Calgary, babies, women, men, teenagers, senior citizens, the entire city have to be inspecting pipelines 24 hours a day, 7 days a week. Forget about banking and financial situations and healthcare and restaurants. Forget about that. The entire city has to be doing pipeline inspection 24 hours a day, 7 days a week, 365 days a year. And we don't do it. I don't know how it's in Lethbridge, but probably you have a traffic reconstruction unit. So if an incident happens on the roads, and right now I'm struck for agent, so you get why it's complex to use robotics in agriculture. If there's an accident on the roads, how many police officers, or how big do you think is the unit that goes and inspect that traffic incident? Give me a number.
2.
Yeah,
50
it
to
depends.
100.
If there's gas on the ground, then they have to bring out the fire
Oh, I
truck.
mean,
Sure, no,
Yeah.
I'm just talking about the police unit. Yeah, 2, 5. I'm not sure here in Lethbridge, right? In Calgary, there's 3 officers. And they cannot cope with the the traffic incidents. They have to go there and they have to make sure that everybody is right. They have to collect the data. They have to do all these things. And sometimes just collecting the data takes time. You know, if it's snowing and they take a piece of evidence an hour after the incident, that information is not admissible in court. They cannot say, oh, look, I got this evidence from this part of, anyways, wherever they collected the evidence, and they said, the judge, this individual is at fault, and this is why. And the judge will say, well, when did you collect that data? Oh, we collected an hour after the incident. And they say, well, that data is not admissible because maybe somebody moved it, the air moved it, it was covered by the snow, different things, and they might be missing lots of data.
But that's the same thing as when we want to talk about robotics.
Yeah.
It's always a moving curve.
Sure.
So the more
So-
we start learning, the more we don't understand in one regard, but at the same time, the more questions we get to ask. I think
Maybe.
it's like, you know,
Maybe, but in the agricultural business, how much data you need to collect to keep these plants safety, healthy, and produce lots? How much data do you collect? Do you collect data? I know you
Yeah.
do. Either visually or you make your prognostics based on what you see, but you collecting data. Do you store it?
Oh, my project's actually with VRI, so I collect a lot.
How much data?
They're collecting data.
A lot, lots of data.
and the thing about it though is that to be able to process the data and do it in an economical way, because
Sure.
it doesn't matter what we do here. Like you're telling me this unit is over $200,000. How do you make it economical to,
That's right.
to
That's
work
right.
it, right?
So-
I mean, and data to manage data, then it's just not going to collect the data. It's having somebody. You have to hire somebody to process data. You have to have,
Sure.
you know, and you got to try to do that all in a.
Sure. And eventually we want robots to do that. I'm talking about data because if you fly in a drone or a ground vehicle to be able to collect all the information that you want to collect, and it's not just weeds, sometimes it's ground humidity, the conditions of the soil, the conditions of the plant. In an hour, when we have been testing our machines, in an hour in a field, we fill a 1 terabyte hard drive of data. And we say, well, now what? We have all this information, and what does it mean? So I think in about 10, 15 years, we're gonna get to this stage using artificial intelligence that the drone is gonna be able to say, this is the information that I have, this is the information important to you. Look what I know. Without we as wearing to crunch the data. And for some people it might be scary, but from my point of view, we need help. Police officers need help. Calgary cannot survive with 3 police officers investigating all traffic incidents. You have to deal with, I'm gonna assume that what I see in front of me, it's a small field. Right? It's a small field. And then you have to collect data of all these things. And I have to be able to know, okay, I'm gonna apply pesticides or fertilizer. And I want to know if, you know, there's a Canadian flag way over there. I want to know if the robot has to spray pesticides in that area, in that spot. And why we're doing this is for you and for humanity to be using better the resources. When you irrigate, do you irrigate specific spots of land or do you irrigate the entire thing? And you don't have to answer me that question, but I'm going to assume that there is a better way in which if a drone or robot can tell you what's the condition of the soil on a regular basis when you need it. They will be able to irrigate, apply pesticides, fertilizers when needed and as needed. That's our goal in terms of robotics. And I think that's coming in about maybe 10, 15 years. Questions?
Like even with the wouldn't you have like even with the drone flying
Yeah.
over your crop, you should still have to ground proof that because you know to make sure.
Sure, and that's why maybe like this institution like Farmer is Smarter, that's what they do. They are trying to do these things and collect data and make sure that the robots are doing what they are supposed to be doing. So that's true, and not just in farming. In many areas, we have to develop techniques and make sure that they actually work. Especially in artificial intelligence. Artificial intelligence is a tool that we can never guarantee 100% that is going to work all the time, because it might work under certain conditions, but the drone at some point might be released in a set of conditions that the drone has never seen before, and it might still provide you bad information.
How
I'm
do
a-
you, how do you see satellite imagery fitting in with information?
It's great.
Yeah.
It's great, and you know what? If we could continue using satellite imagery, that would be super. We don't have to develop all these things. The thing with satellite imagery is that you get your images, and then somebody has to process that information. And I know that some farmers here in Alberta, I'm not sure here in this part of the country or the province, I know that some farmers send us those images to the UK to be analyzed. And then after a week or 2 weeks, they get back the information. And they said, yeah, this is great, but this is old, right? And that's assuming that you can get the satellite images. If it's cloudy and you need data right now, it's useless. You don't have that information. So that's where I see that drones, for example, are benefit. You know, it doesn't matter what the weather is, you can release them. And eventually, maybe not right now under high wind conditions and maybe heavy rain, but maybe in about 20 years, we're gonna get to the point where we can release these machines under those conditions and be able to say, well, this is the conditions, and give us the information when we need it, as we need it.
So I guess it's the same thing with like in terms of flying a plane with sensors in it as well, is that you can still get the information, but you won't have that same like the futuristic capability of the drone interpreting it.
That's
You
right.
have the image. Yeah.
Yeah, and some people have been using, you know, you're aware of cloud systems, right? Where all the processing is taking into place in the cloud. It's great. The problem with in some areas, in some farmers, is that you don't have the connectivity to be sending this information to the cloud on a regular basis, as the drone is flying, so that when the drone returns home, you have the information. So that's another challenge. So sometimes that's why we're using artificial intelligence, because in many cases, the drone will have to be able to do the work that sometimes you cannot do in the cloud, or sometimes you don't have the connectivity, or sometimes you cannot wait. And once again, we have to process all the data that we were talking about. If you ask me how much data I can collect from here, I have no idea. I will be bombarded with all the data. The conditions of each plant, the conditions of each square meter or centimeter, square centimeter of soil, everything. It's impossible. Questions? So now the last topic, I'm not sure how am I in time. 5 minutes. Thank you. The last topic is that, you know, you use heavy machines in farming. Your machines are big. And robots, yeah, they used to be big, but now they are getting smaller and smaller. So it's great. The systems will be more affordable. Do you know, I mentioned to you how much this system costs, right? $250,000, and that's just the base unit. If you add some sensors, it might cost you $500,000. And then you have to maintain it and repair it and sometimes program it. So robots are getting smaller and smaller with similar capabilities. So now the challenge is that you can do the work, but now you have to release lots of them. And so basically what we call swarm robotics. So we have to be able, right now that those things are still in its infancy, but it will be great that you can release a swarm of bees, drones, and they do the work in 5 minutes, and then you have all the information in 5 minutes. For those of you who use drones, for how long do you fly your drone when you fly it? You say 45 minutes it lasts,
Well,
but maybe you fly a couple of times.
We had 3 cameras.
Okay.
So, like,
So for
about 3 hours.
okay, 3 hours.
We're just learning it and
Sure.
experimenting with it, and about 20 minutes of battery.
And that's it, right?
Yeah.
And then you're going to recharge and
It's
start
windy and it's less.
and start busy doing other things.
Yeah.
So we would like to do the 3 hours, reduce it to about 5 minutes. So you say, I want to know now exactly what's happening. You release the drones or the robots, they come back and you know. That's our aim. And because robots are getting smaller and smaller, once again, with the benefits that they are going to be more affordable. Do you know how much, the other page of your handout, there's a Kids ATV that we retrofitted to be an autonomous vehicle. And right now the technology is available for you to retrofit any one of your tractors to be autonomous. And we can do it for about maybe $5,000. That we can retrofit this and make it seed and do things autonomously for $5,000. And still you can actually disable that and you can do it still yourself. As the robot gets smaller and smaller, you will not be able to say, oh, I want to do it, because the robots are going to be tiny. So you cannot drive them. So little by little, we have to rely more on the machine than on the operator. Automating and retrofitting tractors and your machinery, I see as a first step for people to get used to it and start understanding the technology and start understanding the benefits. Not all of them are benefits. There are also some concerns, right? Public perception. You're taking pictures. There's a whole bunch of people, not just in Canada, in the world, that they are concerned that if you take pictures, what are going to do with those pictures? And it's a valid concern. But those people also have to understand why the technology is being used for. There are so many people in Alberta that are trying to prevent everybody from using drones. Because they say, well, you're taking pictures, what are you going to do with that? They're trying to prevent the police officers from using drones to solve a crime. Once again, everything has advantages and disadvantages. We just have to balance everything and make it work. We're the end users. So that's why I'm not afraid of artificial intelligence. It's up to us. Right now, the challenge with AI is that humanity is a certain level of psychology or cognitive understanding here. And the drones and robots are here. So eventually, the drones and robots are going to be over here. So how are we going to manage this? So we have to keep up with us being ahead of the technology so that we can actually use the technology in a beneficial way. It's like many people, right? Many people have been trying to ban cell phones because they have cameras. Yeah, sure, it's a good thing. People are collecting data and sometimes solve crimes and all those things. But some people are concerned. You know, people go into the workshops and take pictures and all those things. It's a concern. You cannot ban knife because some people might use them to kill somebody else. Knives are really useful tools. Without those tools, we will not be surviving in this planet. But anyways, it's up to us. So that's why I'm not afraid of robotics and artificial intelligence. For us, it's a tool that will help us. I know probably already passed my 5 minutes, but last minute questions.
Has there been any success in identifying weeds with drones at all?
We haven't used drones just because we have to deal with occlusions and things, and that makes it more hard. So we have been doing it with ground vehicles, but not with aerial vehicles. And
Success with the ground vehicles?
oh yeah, we identify, depends on the type of weed. We just can characterize specific weeds, but we have been able to do that in a success rate of about 95%. Not all weeds, certain types of weeds, and in certain type of crops. Because once again, there's plants that they look much alike that we haven't tested in those conditions. But yeah, the success rate is growing and growing. Yeah.
I read somewhere where they have like miniature robots that go into your field and cut the weeds.
Yeah. Once again, the success rate of identifying weeds have been increasing.
Well, set them up to a certain size. Anything
Yeah.
below that size, they would cut. You know.
Yeah, and in many countries they are using it, but sometimes depends on, as I said before, the type of weed and things. For me, identifying a dandelion is really easy, right? Yeah. But that's just one weed within hundreds, I don't know, thousands of weeds. I have no idea how many weeds there are. And all these weeds affect your crops in different ways. And you might be concerned about a specific weed versus another one, because they are also competing with the plants, right? And which one competes more with a specific plant type than with the other one. So their success rate, so I think as I said before, within the next 10, 15 years, you're gonna see more of this in the fields because the success rate is gonna be going up and up and up.
All right, if you guys can all join me in thanking Alex one more
Thanks.
time. And it seems like you guys are